The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Mercury Barometer. Let's begin here with a definition. Mercury barometer determines the atmospheric pressure by measuring the height of a mercury column in a sealed glass tube. Initially, we're going to have a glass tube, and it's going to be filled with mercury to the top, and then it's going to be inverted into a dish, such as the one we see here, that's going to be containing mercury as well. Now, initially, the pressure of the mercury, the downward pressure of the mercury inside the glass tube is going to be greater than the atmospheric pressure. Thus, mercury will flow out of the glass tube and into the dish as follows. And if we recall, what is the atmospheric pressure again? That's just going to be the weight of the air, and that's going to push down on the mercury in the dish and push the mercury up the column as follows. Now, after some time, the downward pressure of the mercury inside the glass tube is going to be exactly the atmospheric pressure as follows. And at that point, we can use the height of the mercury column, right? We could use the height of the mercury column right here, right? The height of the mercury column to find the atmospheric pressure. And the height of the mercury column at that point is going to be 766 millimeters. And that is at standard atmospheric pressure at sea level. Now, one other important point that we should note before we move on to our next slide, and we will go ahead and we'll find the pressure exerted by the mercury column, is that as with varying weather conditions and varying altitudes, right, that atmospheric pressure is going to change. And as that atmospheric pressure changes, so will the height of the mercury column. Great, let's continue now on to our next slide here. Wonderful, and we left off right here with the height of the mercury barometer. We had found that to be 760 millimeters, or we could say 0.760 meters. And to find the pressure exerted by the mercury column, we could use the following equation. All we would need is the density times the acceleration due to gravity and the height of the mercury barometer, and we have all three values here. Now, before we actually go ahead and we take a look at the answer here, let's take a few steps back and see how we ended up here. Beginning here with the volume of a liquid. If you recall, the volume of a liquid is just going to be the cross-sectional area times the height, right? The cross-sectional area times the height. And from density, if we want to find the mass of a liquid, we could use the following equation, which is just going to be the density of the liquid times the volume of the liquid. Now, from physics, we know that weight is just going to be mass times the acceleration due to gravity. Now, knowing our first two equations here, we can rewrite our equation here for weight and end up with the following as such. And now if we go back to the equation that we had just introduced a few slides back, being for pressure, and knowing that force is equal to weight, we end up with the following equation for pressure. And once we go ahead and we solve that equation there, we find that the pressure exerted by that mercury column is going to be 101,325 pascals, which is going to be equivalent to 1 atmosphere, right, which is equivalent to 760 millimeters of mercury as such. Okay, great. Let's now continue on to our next slide.